Well, while I'm presenting, I can't see the, members. You can just give me a heads up or anything. Yeah, thank you. You can see a slide flashing on the screen, right?
Yes, Anish.
Thank you. Okay, we are sharp at 10:31. I think I would propose that we get started. First of all, thank you for all of you who have joined the session on time and for members who are planning to join. My name is Anish. I'm part of Harman, and with me is Vimal, who is a co-speaker with me. Vimal, would you like to introduce yourself?
Yes, thanks, Anish. Hi, everyone. My name is Vimal. I work as an engineer in Google Cloud, and I'll also be co-presenting with Anish on the MLOps technologies.
Thank you. So this talk is also been, a lot of inputs have also been provided by Jayaraj. I'm not sure whether he's on the call. Thank you, Jayaraj, for giving your inputs. Jayaraj is part of Walmart Labs. Jayaraj, if you're on the call. Hey, Jayaraj, are you there? Okay, never mind. So I want to thank Jayaraj's inputs for whatever details he has given for this presentation. Thank you. So next 1 hour, we are planning to cover the details about machine learning operations. This talk is at little bit at an intermediate level. There are some basic expectation is that this is not a talk which is basics about CICD. We are expecting that users would be, or who are attending would be aware about the basics of continuous integration, continuous delivery, and DevOps. This has to do with because it is built on the foundations of that. Yeah. Just a note, another note is this talk is jointly organized along with Bspin and ASQ Bengaluru LMC. This would be the agenda about the next 1 hour. We will be covering about Industry 4.0 and ABC, and we'll give a little bit detail about the background about MLOps, what's the foundations on which it started, typically Agile, CI/CD, and DevOps, difference between DevOps and MLOps, how it is complementing to each other, the evolution. And then we will go into the details about the MLOps machine learning operations, the life cycle, how do we build ML pipeline and make it continuously learn, and then how do we deploy. We'll go into little bit more details, and we'll cover some case studies. Right. So a bit of background about Bspin. This talk is organized jointly with Bspin and ASQ Bengaluru LMC. Bspin has been active since 1992 with the support of individuals and organizations and teams like us. Its mission is to help the Indian software industry achieve breakthrough in software quality and productivity. There is a leadership team. I'm sure a lot of members in the leadership team is there today. Thank you for the drive and leadership. I also encourage all of you to be part of members of Bspin, and the details are out there on the screen. We will also put you on the screen later in the chat box. Yeah. ASQ is, of course, most of you would be knowing, is American Society of Quality, is a global community of people passionate about quality. It's a global organization across 130 countries. We have our own Bangalore LMC, which conducts meetups like this. And this meetup is not a one-off meetup. We have been doing this meetup ever for the last 3 to 4 years on the theme of Industry 4.0, Quality 4.0, and related topics. Right. And for membership, of course, you can also see the details on the screen. With this, let me get started about machine learning and machine learning applications in general. If you see, machine learning is being used in multiple different industries, right? Right from retail, for giving multiple levels of recommendations and how the user behaviors are there. Same way for travel, for healthcare. You can predict the diagnosis of diseases easily using some of those machine learning algorithms. For finance, for media, for speech and audio detection, so many other use case scenarios, right? You can also see that modern cars, if you see, we are talking about self-driving car or autonomous car, where most of the machine learning algorithms and AI is built into it, right? It's building on those foundations. If this is a picture about AI usage for cancer detection on the lungs, right? How you can able to detect a cancerous cell maybe much early, maybe 4 to 5 years early than what it's going to come, at a later point of a time. A lot of interesting innovations are happening around on those spaces, right? I don't think there is no further details required that machine learning is the thing, and we are building software today. Many of the things are building on these foundations. Having said that, you can also we would have been aware about this incident of a self-driving Uber car that hit and killed women in 2018. That was the first self-driving car incident that has happened. And if you see a little bit into the detail going to the zoom into the real problem was that I mean, generally the algorithm learns based on whatever the data is fed into that, right? I mean, in this, the pedestrian was not walking on the zebra cross. It was on a bicycle and things like that. So it did not know the data, and because of that, it could not find that, okay, there is a pedestrian actually walking. So it could not apply the brake, and the driver who was sitting also couldn't respond at the same pace. Yeah. The point which I wanted to bring in is that, of course, machine learning is the thing, but the key point is about how do we make the machines learn appropriately? What's the data which we feed into that? The data behind it, the data engineering behind it, that is really matters. And how do we ensure that our models which we are building is not drifting from the data? That is also equally important. So this talk is all about how do we ensure that the modern machine learning algorithms which we are talking about are learning, are better equipped, and we are learning and we are making it better and better. Yeah. The next slide, which I'm going to talk about, is Industry 4.0. We are very well aware that, I mean, this is the fourth industrial revolution, which is across. This is one of those industrial revolution which is cross-cutting boundaries, right? Across technology, across, if you see big data, clouds, I mean, communication, you have protocols, you have manufacturing where innovations are happening, autonomous robots. This talk is not about that, but the key point is about we have a lot of innovations happening around it. But one thing that fundamentally is slightly, if in our view, which comes out very specifically out, is about the large chunk of data which we are generating, right? Large chunk of data which we are generating, and how that is stored, where it is stored, right? It is stored on the cloud, and how we are processing this data, and so on, and how we are using machine learning algorithms or AI on top of it. So that's the ABCs, right? AI and ML algorithms, big data, and cloud, right? So the point is about how do we ensure that we understand this and digitize our organization in a more smarter way, right? With that context, let me give a little bit background about MLOps. What's the fundamental on which it is built on? If you see, there has been movement about agile. Agile is there, yeah, from the last, I mean, 40, 50, 60, or I don't know how many number of years. Agile has always been there. I'm very sure agile is a mindset. We all know that it's not about processes. It's not about only people. It's all about how do we ensure that we respond to the changes, how we stay nimble, and so on, right? And this movement has been happening, and a lot of changes has happened in the industry. We look into software development from a fresh perspective. Of course, we all know about sprint iterations. How do we deliver our requirements in a more faster way, and so on, right? And if you see the extreme programming practices which was built, or which really helped agile, or the transformation towards the faster pace, was the continuous integration and continuous delivery, right? Which focuses on how do we ensure that the single chain which we make in the system, which can go to the production pretty quickly, right? I'm very sure people have different definition of our DevOps. Somebody would say, I mean, the dev and ops, the purpose was to bring the development and the operations team come together. And when we say dev, it means everybody, right? The development, the test, the architects, and everybody in the operations means typically the IT, the operation engineers, and so on. But unfortunately, the industry also has moved in a direction where instead of bringing, maybe I'm not saying instead of bringing, I would say we have bringing departments of DevOps engineers. And I mean, of course, that's good, but the major motivation should be about culture. How do we bring the teams together, and how do we focus on better infrastructure and automation and so on, right? So the key point which I wanted to highlight from this point is that a lot of our need for iterative delivery, quick delivery, is built on the foundation. Guys who are please joining, please go on mute. My humble request, please go on mute. And if anybody from the EC is there, please request you to help in organizing that. Thank you. So the foundation is CICD, which helps in as soon as you do the check-in, there is a build pipeline that triggers, and we are able to deliver faster. And DevOps is the principle by which we are bringing the two different roles coming together and ensuring that we are having a focus towards collaboration, good automation, and a cohesive way of driving and working together, right? And the foundation of all these are automation, collaboration, and details like that, right? Then what is MLOps? Let me just give a little bit background. I know there would be a lot of definitions about MLOps, but in a very simplistic sense, if one thing which you can take away from this talk of an hour, and one of the reasons why we plan our talks for 1 hour, because it's the sweet spot. On a weekend, people don't plan to sit for hours on a call, right, or on a training. So that's the reason it's an hour. So we need to do our best for that. Yeah. So MLOps, what do you see for a production? Okay, what do you see for a code, like for a software delivery? Typically, for the functional code which we are delivering for a normal development, right? We use CI/CD DevOps, right? That kind of a system which we use. Machine learning, in a machine learning system which we are developing, right? The key point is about how do we ensure that the algorithms, the machine learning algorithms which we are using, are staying relevant, right? So, for example, if you are doing if you have developed a machine learning algorithm for, say, a user recommendation, right, for a particular demographics, there may be high possibility that demographics may change over a period of time, right? But the same algorithm may not work. So there is a high possibility the algorithm which you have developed for that particular context may have to be changed. But if you don't change that, the recommendations may go wrong. So that is the reason it's important. The machine learning algorithms need to learn from the data which is fed into that. And it also continuously trains itself, right? So that is the key point. That's the fundamental difference between DevOps, or I would say the normal development which we are doing. Machine learning is different in that context because it relies on the data which is fed into the CI/CD pipeline, right? So what is MLOps? It works on the foundations of DevOps, right? Number one. Number two, unifies the ML system development and the operations, right? It brings both the things together. And it also standardizes the process and technology of building, deploying, operationalizing the ML systems rapidly and reliably, right? So as I told, there is an intersection between it is building on whatever we have developed, the DevOps, the data part of it, and the machine learning. It's the intersection of that, and that's where the MLOps comes in, right? I think most of the folks on the call who have worked on it or aware of this would be well aware about these things, right? At this point of time, I will like to take a quick poll. Folks who are on the call, I would, if you can see my screen, I would, if you can take your mobile phones or whichever machines or gadgets which you are using. This is a Menti poll. You can go to www.menti.com and put the code 2059324, right? Go to menti.com. Please enter the code 2059324 and please answer this question. What is your role in the project or organization? Basically, just to understand what role are you playing, right, in your organization? Are you on the system? I don't see still anybody on the. Can any of you give me a feedback whether you're able to see my screen? Are you able to go to menti.com? I see one user. Okay.
Yeah. Word. What's the word?
www.menti.com. Please enter the code 2059324. Super. So now we can see people coming in. Please go on mute, guys. Okay. Interesting. Vimal, how many members we have on the call now?
We have 30 plus members. Almost 40, 39 members.
Okay, good. I think we have almost half of the members responding. So we have a lot of members on either, I mean, that gives a good demographics about whom we are and what we are doing and so on, right? Thank you for taking up your time to answer this. I'll go to the next question. What is your awareness level of MLOps? If you can give a quick whatever answer you feel comfortable, yeah? Basic, intermediate, expert, or maybe you're learning, whatever your beginner, basic, okay. Okay, thank you. Okay. Okay. Not used often, DevOps is known, not used often. Okay, I think that gives a pretty much good sense about what we are up to and so on. Yeah, thank you. So I think one thing we can also assure, kindly be attentive across the call for the next, I think we have only 40 more minutes left. We would be definitely covering the basics of MLOps. And I think this poll really also helps us to understand to what level we need to pitch in and what level of details we need to go and so on. Yeah, thank you for taking up that poll. Okay, with that, let me go into the presentation mode again. Okay, so by the way, at the end we have a poll or questions based on the whatever we are covering. So stay tuned. Somebody has a question? Okay, if not, please stay on mute. Thank you. Evolution of MLOps. If you see, of course, this is the way it has evolved across the board, right? We have been using open source data science tools. Before that, we have using different proprietary tools for modeling and inferences. Further, we started using Python and R, which is, I think, pretty popular, still popular. Yeah, I mean, most of the machine learning algorithms still use Python and R. A lot of new I mean, the service providers or cloud service provider also has taken leverage right from Google to Azure to, Amazons of the world. They have really taken leverage of that. A lot of the packages are available which are using. In some sense, it has really democratized the algorithm in itself, right, which is publicly available, and we can really play with that very easily. Right. The next part was the containerization, right, where most of the information are available as containers, and then MLOps platforms started coming in. I think now, if you really wanted to develop an algorithm, it's a no non-event, right? If you are signed up with any of these cloud service providers, many of the things becomes a non-event, right? So what are the capabilities which we are talking about? The different kind of aspects are perception, vision, audio, speech, natural language, right? Typically, these are the things which we want to make out based on this machine learning, algorithm we want to predict based on these kind of activities, right? And so on. And what are the different kind of cognition or reasoning we want to bring in? What kind of analysis we want to bring in? It can be either prediction through regression analysis. It can be a classification, right? Male, female, or what kind of animals, what kind of category of product, right? What kind of shirt size, dress size, so many different classifications it can bring in. Pattern recognition, right? Different insights of data which is unknown kind of thing. Planning, optimization, it can give recommendations and so on, right? And there are typical kinds of learning which the AI itself does. Like one is supervised, right? Which it has to be, there is an input, somebody has to really supervise that. There are unsupervised, which does not require any intervention. And there are reinforcement learning, right? You have to it has to learn, keep on learning based on the data that comes in and so on, right? So in a nutshell, if you see, of course, you can go, there is a lot of material out there, which we have also referred, and you can also go back and learn about it. But as a summary, if you can keep this in your mind, that this is what typically we are trying to do in a nutshell, yeah, in the context of this. Typical challenges of MLOps. The one of the biggest challenges is preparing and maintaining high quality data for training the ML models. Yeah, if you put I mean, not so clean data, I would say garbage data inside, you will get a garbage ML model out of it, right? If you really cleanse the data, whatever data you are putting in, you are really analyzing this and really culturing the data and then putting in, you will that will be coming out very well. So the key point is about how do we prepare and maintain high quality data and train this model. The next part is tracking models in production to detect performance degradation. See, what would happen is that your model, once it is there in the system, after one point of time, either the model will decay or because of multiple reasons, right? It will drift, right, from what it was supposed to do to what it is doing now, right? For multiple reasons. So it is very important that you need to keep on reinforcing it or keep on training that and so on. Performing ongoing experimentation of new data sources, right? This is also a big challenge, right? The new data sources keeps coming in, and how do you kind of structure this in a more systematic way, right? This is a kind of also a bigger challenge. And maintaining the veracity of models by continuously retraining, right? How do you keep training and coming out with the right kind of a model out of it, right? And avoiding training serving skews that are due to inconsistencies in data, handling concerns about model fairness and other kind of adversarial attacks and so on, right? These are some of the challenges typical teams face when they are working on such kind of machine learning models, right? I don't have to talk about the benefits. I think we all know. Like in any of the CICD, of course, CICD is the base on which it is working on. Like in dev and ops, we're bringing the development team and the operations team and the test team and the security team and the architecture team and the requirements engineering team together. Like so many roles are coming together. Similarly, in this case, the primary roles like data scientists who are responsible for nurturing the data, data engineering, those team and the machine learning engineers who are actually working on those algorithms. How we are bringing them together closely by collaborating them. This is no more that, okay, they are super smart, one party is super smart than the other, right? How do we bring better collaboration? How do we bring shorter development cycles, right? I would say one of the reason why we are able to bring more innovation in the context of the clinical research, and they able to bring a lot of our vaccines and other things able to bring in the system much faster is because availability of such systems. Otherwise, I don't think we will be able to do at the scale at which we are running today, right? Similarly, increase reliability, performance, streamlined operation and governance, increase return on investment on ML projects. So these are some of the benefits, which is very much similar to what DevOps brings in. If you can think about one of the important takeaway from this training is that three things, if you can remember: the data engineering, the ML engineering, and the app side, application side engineering. So these are the three different streams which we need to keep in our mind. The data part talks about the ingesting the data, integrating the data, curating it, refining it, and flushing the right set of data into the actual, and based on that, the model getting generated, right? That is the part which the data engineering, in some sense, the data ops, the data engineering team does, right? And ML models are built on top of this. The ML models are built and deployed in production using these curated data, which of course, we're going to talk about it. And the application engineering is built on top of that, right? Just remember this: the data engineering, ML engineering, and application or app engineering are the important ingredients based on which this is working on. With this, I'm going to a little bit cover, and I will have Vimal talk about after next 1 or 2 slides about the next details, right? These are the 7 important aspects of ML ops. First, the ML development, the machine ML model development in itself, right? Okay, so the next part is training operationalization, right? Srinivas, you are trying to requesting for control. Can you, I don't know, maybe unknowingly it has happened. Okay, the next part is about training operationalization.
Sorry, Anish, actually it happened unknowingly. Please okay. Ignore it.
No problem. Sorry. Okay, so the next part is training operationalization. How do we ensure that the data which is fed, okay, the data which is fed need to be constantly learned, right? Otherwise, your model may become irrelevant, right? So we cannot just put into production without the data learning by itself. So there is the training operationalization part, continuous training, model deployment, prediction serving, and the continuous monitoring part of it. We are going to talk about this in much detail, but as at a high level, just remember these 7 different aspects for now. Next part is about a little bit more detail at a very high level. If you see, I give the level 1 zoom and the level 2 zoom. Everything is driven by business. What is your business use case? What are you trying to achieve? Right? MLOps is no jargon or some kind of flashy statement, right? There is a background behind it. What is that business problem you want to solve? What is an opportunity you're going to? What is your business use case? The first thing. Second, based on that, for that problem or opportunity which you are sensing, what is the raw data, right? What data you require? That's very important. Next, if you require the data, where from you get the data, you need to extract the data and analyze on it. Once you do that, you prepare the data, right? That's what we talked about in the data engineering, right? You cleanse the data, you remove the noise out of the data, right? In the usual quality context, we say the outliers, right? People who have worked on control charts, they know the outliers, right? Look into those outliers or some special conditions, remove that out because it will create the data will be getting polluted because of some of those noise around it, right? So clean that data. The data is prepared. Train the model, and you may have to train this multiple times, yeah, depending upon different kinds of data that comes in. You train the data, then you evaluate the data. What is the relevant data? I mean, all the different based on the different data types which has come in. You are evaluating this. You have got 3 or 4 or 5 or maybe multiple trained models. Then you compare among the models which is the best model, right? There are ways by which you can do that. Once you have decided that, okay, this is my trained model, you register that and you register for the prediction service and you deploy into actual production and you constantly monitor that, right? In a nutshell, I would like to express this in this flow. Just remember that for now, and I will have Vimal taking over the next part in the detail and the case study. Over to you, Vimal. Maybe you can take over the slide share also.
Okay, sure. Or yes, sure. Thank you. I hope you can see my screen.
It's coming up. Yeah, you can see your screen.
Okay, thank you. Thanks everyone. So I'll be giving an introduction about the core MLOps capabilities required from ML platforms. So most IT organizations will have some foundational capabilities to run your existing IT workloads in a reliable, scalable, and secure fashion. And you'll also have a lot of investments in place for CI/CD capabilities to build, release, and deploy your existing software systems. A lot of these are required for MLOps as well, and many of these can be reused as is for MLOps. But on top of this, you need a set of foundational core MLOps capabilities. These include the capability to do experimentation, large-scale data processing, capability to train models at scale, evaluate models, pick models, and then able to serve models or integrate the models with your existing online services, and then also the ability to monitor the models. So some of these capabilities can be shared with your existing DevOps capabilities. Yes, so who is joining new, please mute. And yes, and along with this, you also need two cross-cutting capabilities specifically to enable integration and interaction. So you will need to have some repository where you can store your ML metadata, the ML artifacts, and also the data set used for your training, experimentation, and also the set of features. So in the coming slides, we'll go dig deep into each of these aspects. The first thing is experimentation, and the capability that is required from the ML platform for experimentation is such that it needs to let data scientists and ML researchers collaboratively perform experimental data analysis, create prototype model architectures, implement multiple training routines. It should allow them to write code in a modular, reusable fashion so that the effort put in by one team can be reused by other teams. And the code should be testable, version controlled. So some of these capabilities again can be reused from your existing DevOps platform. An example here could be notebook environments such as IPython or any other notebook environment where ML engineers or data scientists can do experimentation, track experimentation, analyze and visualize the results, or even analyze and visualize the data models before even picking them, deciding the features, and trying out some experiments. The next capability is data processing, and a lot of organizations today from the era of big data will have a lot of data processing capabilities in-house or using some open source technologies for data processing. And it is required for MLOps as well, because the data, or basically all of the ML algorithms work on data. The more data or the more high quality data you provide, the better accuracy you get in terms of training and prediction. And to ensure that, you need to first figure out from where I can take data, what is the right data for a particular use case to train my model. And the data which is available are generally in the format that is friendly for the source system to generate, not in a format that you can directly consume. So there is some transformation. In many cases, there are transformations that need to be done from multiple sources of data, join them, match them together. And to do this at scale, you need large data processing capabilities. The third thing is model training. So you need to have frameworks in place to train and build your ML models. You could use a lot of existing ML frameworks. Plus, you need to have hardware capabilities to accelerate learning, such as use of GPUs or dedicated ML accelerator hardware, or you can also use ML acceleration cloud. The third capability or fourth capability that you need is model evaluation. So you need to have a mechanism to test out multiple models to be able to compare which model is better. So model evaluation is more of a set of criteria or processes that you put in place as an organization, and that let you gate and define criteria on which you select models, on which you define which model should go to production, which model should not go to production, etc. Model serving, so there is no use of a machine learning model if it cannot be put into production. Put into production, what I mean is, suppose you generate a machine learning model for search recommendation, and suppose you are the lead for a shopping website, and you need to integrate the search recommendation along with the search process, right? So user comes and search recommendation should come. So there is an integration required. So that's where model serving comes in. So your model should be able to serve real-time use cases or batch use cases depending on the requirement of your business. So what is key in model serving is, depending on the use case, you might need to have support for low latency prediction. You also need to have capability for logging and emitting other metadata for monitoring purposes. Online experimentation. So in many cases, even when you don't use MLOps, even in general DevOps, you make some changes to the feature. Even changing a color of a button in many cases is not rolled out to all of the users. You do experiments to figure out which works best. So same thing applies with ML models as well. So you might productionize or integrate multiple models into production, and you might do A/B testing, or you might decide certain cohort goes to certain version 1 of the model, certain other cohorts go to version 2 of the model, and then you see what is the difference in business behavior because of these two models, and then it allows you to use this data to decide and improve your models or decide which model should go into production. And model monitoring. So all the things that we talked about, the last three things we talked about, including experimentation, relies on monitoring. If you're not able to monitor your models, you should not actually use ML models, because it is possible that you put an ML model in place, the model is performing as expected, but it is not letting the business work as expected. For example, again, let's consider the search example itself. Users do search, you integrated a model to recommend suggestions, and if the suggestions are totally out of line of what user is expecting, you will see that your purchases are coming down, or users are spending more time in searching and finding the products. So how you can track the efficacy of your models is not just monitor the accuracy of your models based on the mechanisms that you have designed to measure accuracy, but also measure your business parameters. Depending on the use case, like in the case of search in a shopping site, see the conversion rate. Is your model improving the conversion rate? Is your model reducing the number of clicks or number of searches user has to do to discover product? So you have to use real world signals in addition to your theoretical signals for determining your model performance. ML pipelines. So ML pipelines, you can consider it as an orchestration mechanism that allows you to coordinate different components and build workflows on top of ML. It could be for building the entire ML pipeline in using reusable building blocks, or it could be building composite ML algorithms consisting of more than one ML workflow or ML algorithm chained together. Finally, you need a model registry, because you have, in a large organization, you have so many different teams working on so many different use cases, trying to build experiment algorithms, build algorithms, use data sets, etc. So now if you have a central registry where each team registers the models that they have trained, even experimental models, tag them as experimental, production, deprecated, tag their other attributes such as accuracy, efficacy, etc. It enables discovery in the sense that if there's a new use case, a new team trying to implement or trying to come up with mechanism to use ML in a certain place to improve certain business use case, they can first go and search if there is something that some other team has developed for similar use cases, can I reuse that? So it saves a lot of time for large organizations, saves a lot of time, engineering effort, and cost if you are able to reuse something some other teams have developed. That's where model registry helps. And in addition to these core ML capabilities, there are some cross-cutting capabilities. So the first thing is the data set and feature repository. So consider this, even if you don't use ML, if you are using data for analytics, you will have a huge data lake or a data warehouse where you have a lot of data marts defined, or a lot of data comes in structured and unstructured fashion, but it is tagged discoverable. So similarly, you need for ML as well, the data sets that you use are very similar to the data sets you use for analytics, except that you might be doing some additional transformations. But in addition to that, you'll also have one new thing, which is feature tagging. So you will be extracting certain fields, certain attributes from the data and using it as features for your training your ML models. So you need to augment the capabilities of your existing data repository to be able to even understand something called feature definitions and store your ML specific data sets. So it helps unify both definition and storage of ML data assets. And the second cross-cutting capability that is required is ML metadata and artifact repository. So we talked about ML registry, right? So there you register your models, but you also have a lot of other artifacts, sample codes, schema information, evaluation results, etc. And for all of those, you need a repository where you can store those. Some organizations choose to have it in model registry. Some organizations choose to have separate storage for it, for the ML data and all of the ML related artifacts. And one of the major use cases here is to be able to provide traceability. So if you built an ML model by doing some experimentation, and for that experimentation, you did some data transformation, you wrote some pipeline, the ML metadata repository can provide you lineage, how that entire model was developed, what was the journey, and what are the dependencies of that model. So all of this information can be metadata that is stored in the ML artifact and data repository. And let's now look into one real world use case. So this use case is about a large cab aggregator, which had a large scale customer support operating across the globe. And since there were a lot of customers who were taking rides, not just cab rides, bus rides, even helicopter rides and ferries, there were at least 200,000 to 300,000 different people just requesting support. So in a day, more than 1 million trips are taken, and out of that, at least 10% of the people reach out requesting support. It could be safety issues, payment issues, refund issues, cab cancellation issues. There could be many things. And to support this large swarm of customer support contacts coming in, this organization had 40,000 human beings trained across the globe, working across different centers to support these customers. And each of them cannot handle all of the issues. So they were bucketed. Some people were trained in safety, some people were trained in payment related issues. And again, within safety itself, the safety rules for one country will differ from safety rules of other countries. So they had country specific trainings. And then again, if you come to India, it's possible that in some state, people want to talk in the regional language, and hence we needed agents who are proficient in that regional language. So now when a customer creates a ticket, it has to go to the right person who knows how to handle the ticket. If such company creates a safety related ticket, it should go to a person who knows how to handle that particular safety issue. And if that person has created a ticket in Tamil, it should go to somebody who can understand and reply back in Tamil, right? So the matching has to happen based on the attributes of the ticket and the capabilities of the agent who can solve the ticket. And for this, the older approach was this. We didn't allow customer to directly create a ticket. We showed them a tree of issues, saying that what kind of issue you have. In the first level, you have 10 types: payment, safety, XYZ. And go to safety. Inside safety, there'll be multiple more things: cab quality, driver issues, accidents, etc., etc., etc. And again, you click, there'll be multiple things. So as a user, I have to go through 4 or 5 clicks before I can reach a page where I can actually type what happened. And then on the other side, we need to have a huge number of operational people who actually train these agents and then tag them in the system that these agents can handle this kind of tickets. And somebody does mistagging, the ticket never gets routed at all. So the idea here was to use ML to solve the problem in 2 sides. On the customer side, we wanted to make it more easy. The customer just says what is their problem. The system figures out what is the issue and who should handle the issue. And on the other side, we don't need somebody to tag each and every agent among the 40,000 people that this person can handle this kind of issue, this person can handle this kind of issue. The system has to auto-learn. Maybe we tag them once, but as things change, as people leave and new people join, we don't want somebody to constantly keep updating the system. We wanted the system to learn automatically. So how we did, the problem statement is this. So we need to automatically classify the tickets into different categories, right? And for classification, first thing that is needed is data selection. You needed to figure out what data sources are available in your organization and how those data sources can help in figuring out the category of this ticket. So in this particular example, we use 3 data sources: the ticket information, the trip information, and the customer information. So the ticket has information about what user has typed. That alone might not be enough, because you also need to know what trip the person had taken. If they had taken a cab trip versus if they had taken a boat trip versus if they have taken a bus ride, it's possible that the issue has to go to a different person. And it's also possible that if it's a bus ride, the chance of safety issues coming is less, versus if it's a cab ride, probability the safety issue is high. So there are these things that attribute to the ML training, and hence all of these could be considered as features. And the next thing is engineering the features. So now we figured out what data is there, and next thing is to figure out how to extract or how to clean the data and extract necessary features that can be used to train the model. So here a lot of experimentation happens. Nobody can clearly point out what are the exact features that will be useful in this case. So a lot of human intuition goes here. So a lot of discussion happens on which features are right. A super set of features is selected. Multiple models are ran and trained in an experimental environment, say IPython, and data is visualized to figure out which of the features work better, which features have better correlation with accuracy, and then those features are finalized. Or it's also possible that we could build multiple models with different set of features and then do a selection much later stage. So that's model prototyping and validation. So based on the features, we build the model prototypes, and different organizations, as I mentioned, can have different mechanisms to rank models, or even different teams can have different mechanisms. In this particular case, the teams use something called learn to rank approach, or retrieval-based point-wise ranking. So it's a very simple model where we label the correct match between a solution and a ticket pair. If the match is correct, as +1, score of 1. And we sample random subset of solutions that don't match the ticket and label them as negative. And we use some algorithm called cosine similarity and ticket and trip features and a binary classification to actually determine among these different models which model is better. So all of these together, the experiment, the problem statement itself, based on that selecting the data, feature extraction, experimenting and prototyping model, this constitutes ML development. So this is the development phase. This is where main data scientists are involved. And once this is done, data scientists are not involved much. The next phase is core engineering or MLOps teams. So next thing is pipeline. Now you have the model, you know the feature set, what algorithms is to be used. Now you need to scale it up. Scale it up based on the amount of data you want to use, the scale of the model, etc. You need to be able to build an infrastructure to train that model. So as I mentioned, one of the core capabilities required from a MLOps platform is to have training operationalizations, right? So we need to have capability to distribute our training across a large distributed system. So in this particular example, we had used Yarn and Mesos cluster, and the training was done using batch jobs, which were bundled as containers and deployed in the cluster. And in addition to this, so this constitutes one training flow. Now you need to have a continuous training mechanism or a mechanism to bring data continuously. So you need to build data pipelines. So as I mentioned, in this particular case, we used ticket info, we used trip info, we used customer information, but this information is directly not usable. Why? Because if an organization works across the globe, it's possible that people create tickets in different languages. And if your model has to be trained to understand every different language, it's going to be an impossible task. So what we did is we translated all the incoming tickets into one common language. So that was part of the data pipeline. And then the translations were tokenized, stop words were removed. Stop words are like common words, words that are useless, removed. And then some keyword extractions were done based on frequency and other things, and they were passed as inputs to the training pipeline. So you need to build a data pipeline. So in this case, for data transformation, we use Samza to do the transformations in a streaming manner. We used Kafka as a publish subscribe mechanism where the different systems that have this data, like the ticket ingestion system, the customer database, can send data to the training pipeline. And the transformations that were done had to be stored in a database that can be queried fast. So we had used Cassandra. And in addition to this, the data that we extracted and used for training, we need to have it stored somewhere. Why? A lot of reasons. One is you may have cases where the government rule might say that you should be able to delete some customer data. Right? If you have to delete customer data, you also have to see which models were trained using that data, remove that data set and retrain. Or there could be many other cases where you want to trace the lineage. If a model is not performing well, why it's not performing well, then go back, look at the data that was used to train and try to see if there are anomalies in the data. So you need to also store this data in an archival storage. And we built, or there was a built-in data and feature repository within an organization that used HDFS for the data and Cassandra for the metadata. Metadata is data about the data that we use for searching and discovery. And these together constitute the training operationalization phase. This is how we operationalize training. The ML engineers or data scientists define the algorithm, what feature sets are required. And then it went to the next team, the MLOps team, who built the data pipeline plus the training pipeline to ensure that the training can happen at a larger scale. And all the data used for training is archived. And the next state is model refresh. So now you have a training pipeline, but before you can put the model to production, you also need to have a way to continuously update the model because the business environment can change. The scheme of the data can change. A lot of change will happen. Whenever changes happen, there should be a mechanism where all these changes can go through a pipeline and get updated. So you need to have a mechanism for model refreshing. So during the model refresh as well, we might need to have some checks and balances. You need to evaluate the model that is being updated before it can go into production. You need to validate the model, or sometimes you may want to have some manual mechanisms to tune the model. And all of the models that's updated before going to production goes into the model repository. Consider it as analogous to the data and feature repository, but here what we store is only the models. The model is stored in HDFS as a zip archive, and the model metadata, a lot of information about the accuracy of the model as pursued by the test cases, goes into the Cassandra database. So this constitutes the continuous training. So we operationalize the training. The main difference between training operationalization and continuous training is training operationalization is the first phase where you take a model and increase its scale or train it for a large scale data. That is training operationalization. But then now you have to make this process repetitive. So as data changes, as schema changes, as new data comes in, you want to update and refresh the model to prevent data skews, schema drift, etc. And that is continuous training. And now you have a model, you have a mechanism to keep updating the model. The next thing is using the model. So you need to integrate with the service, whichever service wants to use this. In this case, ticket ingestion system. So in system that ingests the ticket has to use this model to classify it. So there are many different ways you can use a ML model in your service. The three main ways are offline mode, online mode, and library deployment. So offline deployment is where the model is not running continuously. So it is deployed as a batch job. All the request for classification goes into some file or some queue. And once in a day or once in few hours, the batch job comes up, process everything together, and then goes down. So this is useful for cases like photo sharing websites or social networks where you upload photos and then the photos automatically categorize as these are beaches, these are parks, in this there is XYZ person, in that there's a group of people. This kind of classification need not be happening in real time, and they can be offline deployments. But in this particular example, as soon as ticket comes, user is on the chat, they're saying I had a safety issue. It has to get classified instantly, and we need either online deployment or library deployment. And what's the difference between online and library deployment? Online deployment is a case where the classifier runs as a separate process and you make an RPC call. In the library deployment, the classifier runs within the same process as the service itself as a library. And you may ask, how do I choose between these two? Both sound similar. I would say depending on two factors. One is if your model is large enough, it needs much more memory and RAM and GCU, then you go for online deployment. And there could be other cases such as you may want to scale your classifier differently from your service. It's possible that in the service, not all use cases need classifier, in which case you may want to scale the service independently of scaling the classifier. So in those cases, you can go for online deployment. But many cases for simple cases or experimental cases where you are just trying out in production, it might be faster to go with library deployment. And once you have done the integration, one thing you need to do immediately is emit data, add instrumentation, emit data, and use that data for monitoring the models. So in our case, we had used Kafka for the PubSub, again, emitting the data, and Kibana dashboards to build charts out of those data. So we emitted a lot of raw data, and we decided later what of this data would be useful and how we can make use of this data. Now you have done the service integration. Now you also have to update your existing CI/CD pipelines to take into account that this service now also has ML dependencies. So you have to have some additional capabilities such as dynamic ML model loading, because sometimes you may don't want to redeploy your service. You may want to only refresh the model or change the library used in the model, or you want to do some validation of the artifact and serving validations. So these are additional validations that happen in the CI/CD pipeline of the service itself. And this constitutes the model deployment. This is how you deploy your model to work along with the service. And then finally, before it finally surfaces to the user, now your service is integrated with the model. But would you actually roll out this capability to all of the users? No, because if it's not working fine, all of your users are impacted. So you will do multiple things. You will do some experimentation where you might divide the users into batches and do A/B testing. Like a set of users go through the model, rest of the users go through the old workflow and see which one performs better. Some signals that we could use are is the agent to whom the ticket is going, are they reassigning it to somebody else? Or if agent is responding back, are customers reopening the tickets? These are kind of signals we could use to determine whether the model is actually performing well in the real world. So the accuracy metrics like R squared, RMLSC, all of these are good for determining theoretical performance of the model, but practical performance you have to monitor through business signals only.
Vimal, sorry to chime in. If we can summarize in next 2 minutes so that we can conclude. Yeah, we are 6 minutes away from the conclusion. Yeah.
Yeah, sure. So, and then finally, public launch. So again, in the public launch, you'll make use of experimentation and the gradual rollout capabilities. And how you decide the gradual rollout and experimentation is through the monitoring. And then this is used as feedback in production. And finally, to summarize whatever we saw in the last slide, the entire process of end-to-end ML development consists of the development process that creates code and config, and then the training operationalization, wherein you took this code and config developed by your ML engineers and try to operationalize it such that training can happen at scale, and then implement continuous training so that the model is updated automatically as data and schema changes. And then you deploy the model, integrate the model into our service so that prediction can happen within the service, or prediction serving can happen. And finally, you also have monitoring and use this monitoring feedbacks to improve your data, improve your model, or take experimentation actions. And the final takeaway, Anish, do you want to give the takeaway this slide?
No, you can go ahead. You can summarize.
Okay. Okay. Right. So when you use ML in production, right, delivering business value in ML is not only about building the right ML model for the use case at hand, but also you need to be able to integrate the ML properly into rest of the systems. And the ML model should be able to adapt to changing dynamics of business environment. A lot of things could change. Some things could be technical changes like the API changed, or some things could be business changes such as, for example, in this ride example itself, it is possible that this business itself introduced new models. Say, apart from rides, they started giving food delivery, right? Now the tickets that are coming in could be much different, and if the model is not updated to take into account, it might perform very bad. And if you're not monitoring it, it's possible that the team that is responsible for the model was not aware of this new business being integrated. So monitoring will help figure out something is anomalous and then take corrective actions. So developing ML is not the only piece in overall usage of ML in production business, but you should be able to deploy the model. You need to be able to monitor the model, and you need to be able to reuse existing models, the data and feature sets that you have created. Thanks, Anish.
Thank you. Vimal?
Hello, Anish.
I think we are not able to hear Vimal. I thought I lost the connection. Okay, good. So let me share back the screen. Vimal, are you there? Okay, by the time Vimal joins back, I think we have some questions on the chat box. We'll answer that. I have one or two more slides and then some questions on the quiz. If we can, with that, we can wrap that. Yeah. Are you able to see my screen now?
Yeah, now yes.
Yeah, we can see.
Okay, so I think Vimal has had covered the Vimal. Once you are in, maybe okay. Vimal can't hear me, right? Okay. Okay, Vimal had covered this. I think with this we also want to tell that Vimal, myself, and some of my co-authors are also working on a book on software for Industry 4.0, where we are really working on bringing all of these technologies together. Why some of these modern software technology has to be seen in this context, the ABCs and all. We are bringing this all together. We're thrilled to bring this and excited to bring this onto the table for all of us together. Yeah. Okay, so we have taken some references out there. Everything we will keep it publicly available, and you can use these slides, yeah, as you feel right. And Vimal, Vimal, are you in?
Yes, there was a power failure at my end.
Yeah, never mind. So Vimal, I would take the quiz. In the meanwhile, just look into on the chat box. So guys, I would run the quiz question which we had. We'll go back to the Menti poll. Are you able to see my screen? And I will don't look into the answers. Yes. So take all your gadgets and you go to www.menti.com. You have the code out on the top, 72428008. 72428008 is your code. Yeah, we have 6 players. Some more players, 9 players. 10. Once it reaches 15.
Please repeat the code once again.
It's on my screen, 72428008. Are we good?
Yeah.
15. We reached 15. So let's go to the first question. Okay, so answer fast to get more points. What is MLOps? The choices are on your screen. You have 15 seconds to answer. Okay, so right answer is an approach like DevOps developed in the context of ML. Some are a little jumbled out, so we'll go to the next question. Of course, there are some leadership out there. Who has got the maximum point? Srilata and Montana. Okay, we'll go to the next one. Okay. The model is retrained as new data becomes available or if model performance decay is detected. What is this activity called? The model is retrained as new data becomes available or if model performance decay is detected. What is this activity called? Super. Yay. Good. So let's move on to the who is our leadership board. Okay. So we have Raj. Okay, super. Let's move on to the last question of the day. For building an ML enabled system, which of the following are required? Select the best answer. I repeated it while I was covering that. I repeated it a couple of times. So you can look into the right answer. Okay, so data engineering, ML engineering, and app engineering, right? You can of course refer back to the slides. Yeah, just for fun, guys. Nothing, you know. So you can just go back, refresh yourself. But I see a lot of guys have taken it correctly and good. So thank you. And Vimal, I know we are 2 minutes top of the hour. But I would like to just quickly cover those questions. Vimal, would you like to take those questions which were in the chat box?
Yeah, let me see. I'm not able to see any questions in the chat.
Okay, wait a sec. Let me just speak out. I think I saw some questions out there. Okay, the first one, do we have some suggested measures defined for each of the phases for ML ops? Suggested measures. Can you elaborate that question, Srilata?
I think I would. I guess that's all based on the business measures, as you told, right?
Yeah.
And the one on the ML measures. So that is from the product wise. But what about process metrics? So do we do the general quality metrics in terms of schedule variance, effort variance, and all? Or
see, maybe I will take that. See,
yeah.
the general projects. See, the ML ops is like any other project. Okay, it is like any other project which is out there which we are doing. So all aspects related to how do you estimate, what is the end date, start date, end date, effort variance, you know, and all those things matters. But in this context, what is have to seen is that some of the product metrics, I think, which you would have rightly seen, that how fast you can take it to the production, you know, the build failures. Similarly, how continuously you learn, how fast your model get decayed or the model get drifts. Such are the metrics from a more, I would say this is also a little bit on the process side, but on the engineering process side, some of the metrics may change here, right? But otherwise, from a project operation perspective, it is like any other project management best practices would be applied here as well. Hope that answers your question.
Yeah, and one more question. That was my second question on estimation guidelines. So I think it links to the metrics also. So has Bspin been able to get out some baselines for MLOps projects now?
No, not yet.
We used to use for dev projects. We always used to refer to Bspin for.
Okay.
You know,
so there are some things on the card which we as a EC had discussed on this, but
okay.
I think not yet. MLOps is relatively still new, but I think we are also looking for a larger benchmarking on that. But MLOps has not been, you know, we have not been able to bring that, but that is something, a good input. Yeah.
Okay. But do we have some industry standards available other than Bspin?
See, there is an international software benchmarking research data, ISBSG.
Okay.
You can have a look into that. But see, I would say ML ops are like, this is relatively new areas which is coming in. I'm not very sure, or at least I'm not on top of it, that what are the publicly available information out there.
Okay.
But yeah, we need to look into that. Yeah. If you
Thank
come
you.
to know, you can let us as well know. Yeah.
Sure.
So Srinivas has one question. What is the difference Kafka in the publisher and sub in data pipeline and Kafka in monitoring integration? Are these two same? So I think Vimal, it is referred to your slide.
Yes. Yeah, sure. So Kafka is just a framework that allows you to do publish and subscribe. So it is possible that both of these share the same Kafka service, but use different Kafka channels. So in Kafka, you can configure pipes or publish subscribe channels and or topics, they call it in Kafka. So you basically can have multiple topics, one topic for the actual data going in, the other topic which is for monitoring. And basically each topic can have different access controls because the data that is coming in could have sensitive data. Not everybody should access, but the monitoring signals that are coming in need not be that sensitive data. It could be about the model accuracy and things that probably a broader audience could have access to it. So yes, they are the same system in terms of they are the same technology, but they are partitioned. These two are two different pipes or channels.
Okay. Thank you, Vimal. So with this, I would like to maybe, we are already on top of our little bit exceeded the time. Thank you, Vimal. Vimal, thank you for working along with us, Bspin and ASQ to bring this presentation together. Thank you. Thanks to Jayaraj from Walmart Labs, who has also helped us to prepare this presentation. I think things like this, bringing in together as a team has been always challenging, but thank you. And thanks for all the patient listening from the folks out there. Any questions? Do you have any further questions? Any thoughts?
Anish, I have one question. Prasanna here.
Hey, Prasanna, you're there. Hi.
Hi. So, okay, in software engineering, we have an agile principle to keep the faster development phases and faster quality feedback. So in ML ops, is that agile variation thought through to have a faster feedback on the model quality, or also faster development in a much distributed way? Is there any thought on that direction? Or can we apply the exact agile principle of software development into the ML ops as well?
So I will take that, and Vimal can add based on his experiences in different industries. So the fundamental things are exactly same, Prasanna. I mean, we are building, MLOps is just building on top of whatever we have learned. This is like application of agile and DevOps on machine learning projects in very simple sense of things. But having said that, there are some new practices which is being brought into this context, like how do we bring data engineering in this context, because there are new roles also coming in which is typically missing or maybe not there so closely, right, in some of these things like data scientists or data engineers and things like that. And there are a lot of practices around it which has to be brought in. Number one. Number two, that how do we ensure that this model is continuously trained? So there are practices so there are engineering practices that is going through a lot of change, like continuously how do we train that? Unlikely in other continuous delivery build pipeline, we don't train our build pipeline constantly, right? But in this case, we are training it constantly through whether there are data which is coming in and so on, how do we kind of retrain and so on. But the fundamental principles of agile still remain same, but I would say the engineering practices has some bit of change, especially on the ML side of things, data engineering side of things. But Vimal, if you would like to add anything on whatever I said.
Yes, what you said is right. It's quite similar to the existing processes in terms of implementing agile. But again, a lot of things in ML are relatively new, and the experimentation aspect is there. Unlike traditional software engineering, where there is more degree of certainty, in ML there is a slight degree of uncertainty, and the processes need to be flexible to accommodate that.
Okay, so thank you very much for the active listening, and thanks for the participation. Thank you, Vimal. Thank you, Jayaraj, for all your contributions. Appreciate it.
Thanks, Anish. Thanks, Cheriyan. And thanks, Bspin, for this awesome event.
Thank you.
Thank you. Bye-bye.
Bye-bye.